Hi, this is your host Sabin Bharti and welcome to TFI Newsroom. And today we have with us executive from Snyk. Is that right? Did I say it right?
From Snyk.
Snyk. Good. So first of all, Geva, can you introduce yourself? What do you do and what does the company Snyk does? It's a cool name. I will get into the history of the name as well.
Sure. So my name is Geva Solomonovich. I'm the COO here at Snyk. Snyk is a security company trying to help developers use open source and stay secure, like says here behind my back. And you know why is that important? So today, 90% of the application is open source code. And when developers pull open source into the applications, each one of those packages, has a life cycle of its own. They release versions. They find bugs, they fix bugs, they find security bugs, they fix security bugs. And it's really hard to keep track of that when developers are practically focused just on their own application and barely have time even to write that. And all this gets even more compounded when you consider that each open source dependency is using other dependencies, which use other dependencies. And so to manage that entire dependency tree where each package has its own life cycle is almost completely impossible to do for a developer. And that's where automation and security tools come in. And that's exactly where Snyk tries to play.
If you look at, since you mentioned open source, if you look at the application development or distribution in the open source world, there were two models. One was, package manager where you have RPM, deb, and all, or you can go Arch route and you can package build yourself. The second route was that containers were introduced. Containers were part of Linux for a very long time, because username is space and everything else. So they try to solve that problem. Then you have snaps and Flatpak, and a lot of things are coming up. They all introduce their own set of problem with package managers. The distribution, they become the gatekeeper. You have to be in their repository. If you have your own third-party repository, then you are running the risk of running some random code. The problem with containers was that you are downloading random images from Docker Hub or whatever it is. You have no control over what is in those packages. Somebody can hardening to some repository and suddenly you're everything. So can you talk about these two before we get into this, how you are trying to solve the problem?
Sure. So Containerland, you're right. It developed really, really fast, and Docker Hub became very successful, almost to a point where everybody's publishing there, and when you try to consume from it, you're not really sure what you're getting and who published it there, and that by itself is a risk of its own. How do you know you're not getting a malicious image? How do you know what's in the image? And all these questions are really hard questions. To solve it at a broad ecosystem level, Docker themselves and other registries, following, try to have this area, called something around like a certified images, where the company is authoring, say, hey, I handcrafted this, so I know what's in, and I certify it, and it's not going to be malicious because us as a company put it here, and it's not this random. Random place, a random image that's in the registry. And so why don't you pull from here instead of what's in this open zoo? This is one angle. The companies on the other angle, a lot of them have the same equivalent on their side, where a small team inside the company go and handcraft all these images, say, hey, somebody spent the time and energy to put all this stuff here and knows what's there, and then allow their own developers only to pull from that kind of whitelist or the gold set of approved images. But specifically saying in a broad sense, it is a challenging problem, and it's really a problem where you do need tools that tell you what's happening inside the container, what's images inside, how does those relate to other base images that they refer to, and how those relate to other base images, what are the vulnerabilities that are being pulled in, what are the license issues that are being pulled in. So all that is really hard to do manually. And all that is actually lends itself very well to automation, and so that's where the security tools come in for the help.
So where does Snyk enter the picture to solve the problem for both? Microsoft Azure, as a platform that is offering at the same time people who are using it.
Sure. So in Containerland, we look at a few things, I would say. So one, functionally, when you point Snyk to an image, we we can scan it. We'll tell you what's inside, what packages are inside, and what vulnerabilities are inside. And so there's a lot of container scanners out there, and so that's a good value by itself. But where it becomes more interesting is actually where we do the scanning in the development lifecycle, and what kind of tooling do we give there. And so we try to go all the way left to the developer, helping the developer make smarter choices as they're building the image itself. And so in the modern age, the developer owns the Docker file itself, but they're typically not informed. And so how do you know what base images are good to pull from? How do they know what vulnerabilities they have? And more specifically, how do they know what is the next best step they can do to improve their security posture? And so what we found is that over 90% of the vulnerabilities come from the base image, and not from the specific lines of code that the developer adds into the Docker file. And the developers need a very, very simple and elegant way to know, one, how many vulnerabilities are coming from the base image, but two, when there's a new base image that's released that they can upgrade to that will eliminate their vulnerabilities, or sometimes there's even an alternate base image, typically a more slim one, that's pulling in less dependencies and obviously has less vulnerabilities because of it, but it will still satisfy the developers' needs in terms of what's inside the image. And so, for example, if you take the latest node, base image, it has hundreds of vulnerabilities. But if you're okay to take a node slim image, then it has significantly less vulnerabilities. And if you want to take maybe an Alpine distribution of the image, it even has maybe less vulnerabilities. And all this stuff is typically stuff that developers don't know, but Snyk actually lets them know and helps them make those smarter choices from the get-go.
Perfect. While we're talking about security, there's one more core problem that's associated with the way containers work is compliance with licenses that you're using, because you're shipping packages, but you may not be shipping all the requirements, whether it's notification or source code. So do you deal with that also, or that is outside of your scope?
No, absolutely. So license compliance is a big issue, right? You're pulling in these dependencies. They have licenses. There's many different types of open source licenses. Some of these dependencies have dual licenses, and so all that complexity is really hard. And again, the dependencies, the top level dependencies that you're explicitly pulling, they're pulling in other dependencies, which pull in other dependencies, and you're susceptible to the licenses of all of those, the direct and indirect ones. And so one of the things that we do really well is the moment we observe your application or your container, we look through all the entire nested dependency tree, pull out all the licenses, tell you first, here's a list of observed licenses, which is something legal teams really like, but also allow you to apply policy on it and say, hey, GPL license is not good for my application in this type of context. And so can you help me surface up all the GPL licenses? And maybe during a CI/CD, you want to reject the deployment of a container or an application that has one of those licenses which don't meet your criteria.
You're also announcing a partnership with Microsoft.
Yeah.
Talk a bit about that. What is it all about?
So this is an amazing partnership with Microsoft, right? And what's the story here? What's the story with the cloud? If you're just taking your application, which was running in a server in the closet, and putting it in a compute instance in the cloud, you're probably getting nothing. You're actually it's actually costing you more and getting you less. And so where is the value of migrating your applications to the cloud? It's in a few things. Typically embodied under an umbrella called the digital transformation. One, you need to use more than just compute services from the cloud to get more from the cloud. But two, you need to change also your methodologies. And so you need to be thinking about automation. You need to be thinking about CI/CD. You need to be changing your architecture. You need to be thinking going more towards microservices architecture. You need to be thinking about cloud native technology, so leveraging containerized workloads, serverless workloads. And the last element to that is also you need to change or shift the way that the people collaborate around all this to achieve continuous delivery, to achieve speed, and to achieve scale. And all those together are enabled on a cloud in general, because the clouds have all these different services. Specifically, Microsoft has Azure repos, has Azure pipelines, has a container registry, has a Kubernetes service, has Azure functions. And if you're smart as a user to leverage all of these, then you get so much more value. But what's a trick? When going to the cloud and going full automation and doing hundreds of deployments a day across hundreds of applications, it's very easy to lose control, or a lot more of the control is going to the hands of the developers. And so you need two things here. One, can I give the developers the right feedback to make smarter choices in terms of security as they're building those applications on all these containerized or cloud native workflows? And the other one, can I give still the security people the visibility they need and the governance and control the knobs and the widgets of the tools to give the developers the right feedback when they're developing it to make those smarter choices? And that's exactly where Snyk plays in and comes and helps companies take their payloads to the cloud in a more secure and safe way. And specifically, we have integrations around the Azure repos, which is their source code manager, their Git source code manager. And because Azure repos and all the other services have both APIs, through those APIs, we can connect to Azure repo and instantaneously, one, discover all the applications, two, put ourselves on the webhooks so we can scan automatically on every commit, every developer commit, on every pull request, and so immediately bring ourselves into the developer workflows. In addition to that, we can now send pull requests back into those repos, actually doing the fixes for the developer. I'm just going to send you the code changes into your repo, and all you need to do to fix the vulnerabilities is accept it. And so mentally, I'm now asking for the developer for something very small to accept a pull request, which is way, way, way better than going and reading all the security advisories and reading the remediation advice and trying to figure out if they're doing the right thing. I can also do prevention. As the developers are writing pull requests, I can check if the pull request is adding new vulnerabilities that weren't there before, and tell the developer, hey, this change that you're making right now is adding new vulnerabilities that weren't there before. So why don't you go and take a few more minutes and do something alternative before you merge this pull request and fix this vulnerability way before it gets into production. But then also there's Azure pipelines, and so this is a CI/CD tool, and there we can scan again, and there we typically enforce that that application or the container and application meet the policy of the organization. It doesn't have high severity or critical vulnerabilities. It doesn't have undesirable licenses. Again, GPL or not, that depends on the context of the application. And that's where we give the security team the control to govern, that choke point, make sure nothing gets deployed. You have the container registries. So through APIs and webhooks, again, we can connect, we can discover all the images, we can scan both on the upload into the registry and on the download from the registry. So don't allow to publish containers which don't meet your specification, and don't allow to pull containers which are no longer meeting your specifications. We can integrate with the Kubernetes service. And so, hey, let's not deploy here images that Snyk hasn't scanned before anywhere before in the pipeline. And so prevent developers from accidentally deploying rogue images or images which are not approved. And then also we go all the way to deployment when you're looking at serverless payloads and Azure functions. You can point Snyk to your Azure functions deployment, and we will discover all the functions which are there. And again, we can let you know what vulnerabilities they have, but also more importantly, we continuously monitor them because new vulnerabilities get introduced all the time. And so we can alert you if there's a new vulnerability that's impacting one of your existing functions.
Perfect. Awesome. When we talk about migration or digital transformation, first of all, digital transformation is not a destination. It's a process. As you mentioned, serverless, function as a service. So new paradigms will come in the next 6 months or more than that. So when you work with those customers to enable them to migrate to cloud native world or cloud world, what is the biggest pain point and challenges you have come across that these customers face? Is it technological? Is it mindset? Because you said you have to change your mindset as well. So can you talk about that?
So one of the big one I would say again is the people element, right? The mindset, the processes. Because if you're thinking about the old days, when there was 2 releases a year, and security people would come with their security tool belt, they would run a scan for a month and say approve or don't approve the release, or go fix this, go fix that. And nobody liked it back then, but it was fine, it was functional, it was working. And today, when you have continuous delivery pipeline and there's hundreds of deployments per day, that checkpoint disappeared, but you still see the old security teams using old style security tools and running those scans. But the question is, okay, what do you do with that scan? Because it's not going anywhere. And so there is where you can imagine a security person running around with a security report, trying to get a developer to fix something. And in that context, the developers are hiding under the desk because that security person is the biggest nuisance. You're stopping me from my work. I want to do my feature. Why are you telling me to go fix this something I did last year or last week, et cetera, et cetera. And so in the new age, you need to get the security in the hands of the developers as they're building the applications, so they can make those smarter choices on the get-go. The security person's position needs to elevate to governing this whole process and to controlling the knobs and the widgets inside the tools. And when you do that, you get 2 amazing things. One, you get a true shift-left movement. You find and fix and prevent all those vulnerabilities earlier. And there's many graphs showing that it costs $5 to fix it during dev time and $5,000 to fix it during production. But you also get security at scale. And why do you get security at scale? Because most of the organizations have 500 developers for every security person. And so as much as you can build a tool that developers want to use, they like to use, and actually use in part of their SDLC, you get so many more people participating in the fixing game, and that gets you the security at scale.
Perfect. I think we have touched upon a very broad set of topics. We talked about the problem with the package managers, the containers, and then the challenges, and then what services you offer. We talked about licensing, and anything else you think was critical to this discussion, or something you would like to highlight out of this discussion? Or you think we have covered everything?
I think we covered the big important things here, right? So the cloud. If I can just summarize, the cloud gives you all the opportunity, right? The baseline of the technology is there. And then to reap the benefits, you really need to know how to leverage it, to change your methodologies, and to bring in tools that help promote everything to be autonomous, and shift the responsibilities properly between the different constituents, the security person, the operations person, and the developer person. And that shift is often the more challenging things, and building tools that help promote those changes in the ownership. That's the hard part, and that's one of the things we've done very well with Microsoft. Help everybody get the right feedback that they need during the appropriate point in the development lifecycle on the Azure services.
Awesome. Thank you, Geva, for talking to us today and explaining the partnership with Microsoft Azure, and also touching upon all these security and licensing related topics related to containers. And hopefully we'll see you again soon. Thank you.
Thank you. Thank you for having us.